Okay, so we're asked to find or determine the type of growth pattern that is shown here. Is it linear, exponential, or quadratic? We're going to determine the total number of squares in the sixth pattern, sixth step in the pattern, and then we're going to write an expression for this pattern. So when I don't have a table, I like to start with the total number of squares or terms in each step. So I'm going to start by doing that. So step 1 has 5 squares. Step 2 has 9 squares, and step 3 has 13 squares. And we may need a step 4. I kind of like having a step 4 because sometimes I don't think 3 is enough to establish a really solid pattern. So how are these numbers changing? From 5 to 9, that is a plus 4. 9 to 13, that is a plus 4. And so what do I notice is the same in this pattern and what's different? So let's look at that. Well, I notice there is a square in the center, a square in the center, a square in the center. What is different for this? I notice you have some squares going out from the center square. So in the first, 1 on each corner. In the second, there are 2 squares on each corner. In the third step, there are 3 squares coming from each corner. So in order for me to figure this out, I want to draw the fourth pattern. So according to what I'm seeing, I should have a square in the center. And then in this one, I should have, oh, let's change the color there. No. I should have 1, 2, 3, 4. Let's go again. 1, 2, 3. I'm getting better with my 3, 4. Do that from the other corner. 1, 2, 3. Oh, come on, Mrs. Thomas. 4. And then from the other corner, 1, 2, 3, 4. So again, what are we noticing? Oh, that's the same, but the number of squares coming from each corner is what's different. So what's our total number of squares here? Well, that is going to be 17. So we have 17 squares on step 4. So from 13 to 17, that's another plus 4. This was plus 4. So we notice that there is a constant rate in this case. And so as we were saying initially, what stays the same is the square in the center. 1 square in center. And then what's changing what's changing is the number of squares on each corner. So if we were to establish a table to try to figure this out, where our x is our step number and our y is total squares, then on step 1 we had 5, step 2 we had 9, step 3 we had 13, step 4 we had 17, and we're noticing something. So when we look at it, this is the number of squares on each corner always happens to be 4 times the step number. So it's always 4 times the step number. So we can consider this as 4 times x, and then there's 1 square in the center, so that's a +1. So the expression would be given by 4x plus 1. And then because there's a constant rate, we know that this is showing linear growth. So we're going to say this pattern shows linear growth because it has a constant rate of +4.